This is the last set of questions for problem number 3. It says we're looking for the mean and the sample standard deviation, and then it gives us information about grades. If this is to be curved, then a C level would be 1 standard deviation above and below the mean. The B level would be between 1 and 2 standard deviations above the mean, and the A level would be 2 standard deviations above the mean or higher. And then same goes for the opposite side. And so they want to know what we need to get a C. Alright, let's answer the questions. Let's take a look at the mean and sample standard deviation first of all. As long as your data is already input in your calculator, you can do all kinds of stuff. Here we're going to hit stats and calc. We're going to do one of our stats on L1, and we're going to get everything that we need. For us, we're just looking for the mean and standard deviation, so this should be it. The next piece of information they're asking for, oh, by the way, the standard deviation that we are looking for is the sample standard deviation, and it is important to identify the sample standard deviation versus the population standard deviation. So our mean is x bar, our sample standard deviation is s, and we are hardly going to be ever using the population standard deviation sigma. So if you want to just cross that out and not think about that, we're going to be focusing on your SX, your sample standard deviation. So the next question, what exam score do you need to get a C or higher? A C or higher is 2 standard deviations. What I'd like to do is I usually like to, let's see, let's clear out this calculator. I want to see a breakdown of this and identify what it means to be 2 standard deviations above the mean and 3 standard deviations above the mean, etc. So let's take a look at our 20.4 as our mean, and then if we're going to add 1 standard deviation, I'm going to add 13.5 as our standard deviation. So 1 standard deviation above the mean is 33.9, so that's going to give us the top C range. To get the bottom C range, I want to do the same exact thing I have in my calculator up here, my last entry, except instead of a plus it's a minus. So I can recall my last entry by hitting second function and enter, and I'll move my arrow until I get the plus sign and hit the minus sign, and then I'll press enter, and that's going to give me a 6.9. So a score of a 6.9 or 7 on the test would give you a C. Anything lower than that would give you a D or an F. So we can continue breaking this up and looking for the B range. So the B range starts from 33.9 or 40. A score of 40 would give you a B, and then we can take a look at what the cutoff is to the A range. So I'll take my last entry again, and now I want to add plus, and I want to add 2 standard deviations. Now I need to insert, because if I just type in the 2, I'm going to start overwriting this. So I press second function and insert, and then I'll say 2 and then times, and then that's going to give me my 47. So to get from the B range is to go from 33.9 to 47.4. So anything above 47.4 would give you an A. Alright, so that's the setup for that. So what exam score do you need to get a C or better? Your exam score to get a C or better would be about 40. This is 1 standard deviation above the mean. The empirical rule is something a little bit different, and I just realized that it wasn't covered in the textbook, but I think it's easy enough to examine. The empirical rule takes a look at data and assumes that if it's fairly normally distributed, then your data is going to be broken up in this way. Within 1 standard deviation of the mean would be about 68% of your data. Within 2 standard deviations from the mean would be 95% of your data, and within 3 standard deviations of the mean would be 99.7% of your data. This is really works a lot better for large amounts of data, but we can apply it here. According to the empirical rule, students will receive an A or an F. Remember, an A or an F is 2 standard deviations above or below the mean. So within 2 standard deviations you get 95%. So it looks like between here and out here would be the complement of 95%, which is 5%. So it looks like we'll get about 5% of our data will be above 2 standard deviations of the mean or below 2 standard deviations of the mean, which gives us an A or an F. Alright, so that takes care of those set of questions.